Hello everyone, welcome back to Let's Crack J in English, the channel of Unacademy. So I am Jeetendra Dixit. Here is my profile. So I did my BTech from IIT Kanpur and I have been mentoring IIT-JEE aspirants for last 11 years. So we were doing mathematics and in this session I'll discuss functions. Basically it's a revision session. So specific, not complete function, but mappings and some problems based on domain. Okay, so in this session I'll discuss mainly mappings onto one, many one, and permutation and combination related to mappings, like counting how many one mapping and many one mappings are possible. So all these things we will discuss in this session. It will be beneficial for those who have done functions once at least. Okay, so those who have done it once, they can get benefit out of this session. And those who are doing it for the first time, it might be difficult because I'll be picking up some good questions for this session. Okay, and theory I'll do quickly. So yeah, 1 minute. So before the beginning, let me tell you about the Unacademy subscription. So as you know, Unacademy is India's largest online learning platform. And you can subscribe for Plus as well as Iconic subscription. So if you are taking Plus subscription, then you get daily access to daily live classes of all the JEE educators who are teaching there. And you can follow any of the educator of your choice. There's no restriction. Unlimited access you get, and all tests and all live quizzes will be accessible to you. All these courses are well structured, and if you're not taking Plus subscription, then you can attend special classes. The special classes are completely free. Unlimited special classes you can attend, and every day there are many educators who are taking special classes on various topics. So you can just download the application and watch these special classes without taking any subscription, without paying anything. Or like these YouTube videos are also free. You can watch unlimited YouTube live videos like this session. These are the subscription charges. You can subscribe for 1, 3, 6, 12, and 24 months. And for 12 months, you'll have to pay this much and this much. If you use my code JEET1, you'll get 10% discount. You'll have to pay this much, 34,650. So you'll get basically 10% discount if you use this code JEET1. All right. Now let me tell you about the Iconic subscription. So Iconic subscription is a subscription in which you get personal attention apart from all the benefits you are getting in Plus subscription. So those benefits will be there. You will get unlimited access what you were getting in Plus subscription. Apart from that, you'll get personal coach who will guide you throughout your preparation for all topic sums. Okay, all your align your preparation strategy making and everything. Your test analysis will be done in a personalized manner. Your feedback will be given to you to improve your time management and exam approach. Okay, and similarly, study planner will also be in a customized manner. All study plan, weekly reviews, and highlight your progress. So everything is in a personal manner. So you'll get this personal guidance, personal coach. Okay, expert you can say if you take this Iconic subscription. So this was Iconic subscription. You'll have to pay 56,000 for 1 year subscription, and after 10% discount, that will be 50,400 if you use this code JEET1. Similarly, 86,000 for 2 year subscription. If you use this code, 77,400 you'll have to pay by using this code. So use my code JEET1 to get this 10% discount. All right. So this was about the subscription. Now you can download this Unacademy's learning app from Play Store. This is the app, and make your account and start watching special classes first, and then you can subscribe. Let me check my voice before it is fine. Yeah, perfect. Okay, so functions, mappings. Let me tell you mappings, kind of functions, types of functions. So first of all, a function which is defined from A to B, set A to B, set A to B. What kind of relations are called functions? So if you have a set, sorry, let me make a set like this, and this is set B. Okay, so basically what we are doing Set A has some elements, say x1, x2, x3, and so on up to xn. So I'm taking n elements, okay? And y1, y2, y3, and so on up to yr. Let's say r element, okay? R elements. Then total number of mappings. What is the condition for a mapping from A to be a function of mapping? Every element of set A, every element of set A should map to one element of set B, and no element should have more than should map to more than one element. All right. Let me repeat. Every element of set A. Okay. When you map, let me tell you one word. Some terms, terminology. So if you map x1, y1, that means y1 is called image of x1, x1 is called pre-image. Okay. So y1 is called image of x1, and this x1 is called pre-image of y1. Okay. So what are the two conditions for this mapping to be mapping from A to B to be mapping of a function? The conditions are every element of 1 minute guys. Every element of set A should have an image in set B. All right. This is the first condition, and no element of set A should have more than one image. That means it can't be like this, okay? This is not valid. So one element cannot map with two. It should map with only one, okay? So this, the pre-image, which is also called the input, and y1, which is called the output. Okay, so put whenever you suppose this is a function, if you put one input x1, you'll get only one output. All right, you should not get two outputs. Yes, it might happen that for two inputs you can get one output. That might happen, that is allowed. So that means if you have x1 and x2 are mapping to same element, that is allowed. Okay, that is allowed. This is not a problem. Okay, this is not a problem. So what was the first condition? That every element should map. Every element should map. Okay, no element should left out. Yes, in B there might be some elements which are not mapped with any element of set A. That might happen. Okay, but every element of set A should have an image in set B. Okay, you can't leave any element here in set A. So such kind of mapping, like this is a mapping, this is a mapping of a function. You can call it mapping of a function. Okay. So example, if you write y is equal to x square, this is a relation in x and y. So whatever, this is a function of x, okay, we are calling it a function of x. Function of x, that means x is the input and y is the output. So if you are putting the values of x in this, you get only for one value of x, you'll get one value of y only. All right, this function you can define from r to r. Okay, r to r. That means for every real value of x, you'll get one output. Okay, put anything in this, you'll get one output. So this equation is representing a function. All right, this equation is representing a function. I hope it is clear. And graphically, if you want to see function y is equal to fx. So if I make a graph like this, if I make a graph like this, if I make a graph like this, all right, then this is mapping of function from A to B. This is your A and this is B. So A to B, if you, this is your A is called domain. Okay, this is called domain of the function, and this is called codomain, right? Codomain. And what is range? The outputs you're getting here, the set of outputs, like yr is not there in this mapping. Yr is not output of any element. The set of output is called range. All right, so range might be equal to codomain, it might be a subset of codomain. So in this, if you're drawing a horizontal line, if you draw a horizontal line in the graph of y is equal to fx, and it cuts the graph Okay, no, sorry, not horizontal, vertical line. That horizontal line is for one function. So if you're drawing a vertical line, vertical line. So if you draw a vertical line and that cuts the graph only at one point, that means for this input you are getting only one output. This, all right. So this any vertical line should not cut the graph at more than 2 points. Okay, then that graph will represent a function. So yes, that is the case. So this is a function. In this also, you draw vertical line anywhere, it will cut this graph, y graph of y is equal to fx only at one point. So this is also a function because for every x you'll get only one y, right? But for this graph, if this line, vertical line, you plot, this will cut the graph at 2 points, right? You can see this and this. That means for this x you are getting two images, y1 and y2, right? So if its graph is like this, then this is not a graph of a function, all right, from y to fx. So this is a way to check it. As I told you, it's a revision class, so I'm just doing it quickly, all right. So I want to basically come on the mappings 1 1 and many one types of mapping. So what is 1 1 mapping? So if you xn y1 y2 y3 yr, okay, this is a and this is b. To a to b, those mappings are called mappings of a function if, what is the condition? If no two elements of set A have same image in set B. Okay, so 1 1 and let's add many one also. Okay, in the last slide I want to add total number of functions in this. Okay, so total number of functions, let me tell you. Okay, when you are doing this mapping from A to B, now I'll explain this properly. These are basically boxes, because you can see two elements can map with same, two elements can have same image in a function. Even three, even four, even five can have the same image. All right. So that means these are like boxes and these are like things. So you need to put n things into R boxes, and empty boxes are allowed, but you need to put all n things, okay, in these boxes. That might happen that all these things will go to one box, like all are mapped to y1. X1 is mapped to y1, x2 is mapped to y1, x3 is mapped to y1, x1 is also mapped to y1. That's a constant function. That means you're putting anything, you're getting y1 only as output. Okay. So total number of function. So if you give the options to this element, this x1 has r options, x2 also has r options, x3 also has r options, like putting n things into r boxes. So total number of functions will be r raised to n. R is the number of elements in codomain and n is the number of elements in domain. Then r raised to n types of mappings you can form. R raised to n distinct mappings. That means you can form r raised to n different functions you can map. So these are total number of mappings of a function from A to B. So this was the formula you need to remember. Now we will count. Okay, first understand 1 1 mapping. No element. Now he is saying that this is not allowed. Now this is not allowed. Okay, this is not allowed. This was allowed in function but not in 1 1 function. So if every element has this, no two elements have same image, then that kind of mapping of a function is called 1 1 mapping. So it will be like this. It will be like this. It will be like this. All right. So all elements are mapped. All elements of A are mapped. That is the condition of a function. And no two elements have same image. Now it's not like a box. Initially, what you were doing when you are creating mappings of a function, you are putting, you are giving first element are options. Okay, first can go to any of the box, and second also you are giving the same number of options irrespective of the thing that first element is gone to y1, x2 can also go to the same box, but that is not the case now. Now x1 and x2 cannot go to the same place now. So to understand this, what we are going to do, we are taking these elements, not boxes, but like chairs. Okay, these are like chairs, seats. It's better to write seats. So these are like seats. So n persons and r seats. So what will happen? And obviously seats r जो है that should be greater than or equal to n. There should be more number of seats or equal to the number of persons available, because every person is going to sit, right? That is the condition of a function. And now the further condition for one function is that no two persons, no two elements of A, I'm calling elements of A as persons. So no two elements will sit, again, I will go to the same seat, all right? Yes, so that's why we have assumed seats, because one person occupy one seat. So how many ways you can do that? In how many ways you can occupy? So you can select n seats first of all, RCN, all right? R is greater here, or R is greater. You can take M if you get confused with R. So take M, all right? M. So M is greater than N. So I'm taking M elements in set. So I'm taking M elements here, right? M seats. So M is greater than N. So first you select N seats and then you arrange N persons. So N factorial you can arrange in N persons can be arranged in N factorial ways, and which you can write MPN also, right? Directly. So total number of one functions. And what is total number of, if you take M elements, R is equal to M, then you can write M is M raised to N also, right? Because I'm using M here. Then if function is not 1 then it will be many one, okay? That means if no two elements have same image, then it is 1 If at least two have the same image, then it will be many one. So either of the case will be there, right, in a function. So if function is not 1 then it will be many one. So what is many one function? Total number of many one functions. That will be total functions. Total functions, how many total functions you had? X1 m options, x2 m options, x3 m options. So m was multiplied to n times minus mpn, okay? So total minus 1 total minus 1 will give you many one functions, okay? Now let's understand what kind of graph a one function and many one function will have. So we know what kind of graph a function has. So I'm giving you two options here. One graph is like this, other graph is like this, right? Now see which one is the graph of 1 and which one is the many one. So if graph is either always increasing or always decreasing, okay, always increasing or always decreasing, it will be 1. So that means here you can plot a horizontal line. If this horizontal line cuts the graph only at 1 point, okay, that means for one input you're getting one output, okay. If it cuts at more than 1 point, that means like this. Here you can see this horizontal line cuts, any horizontal line cuts the graph at more than 1 point. That means it is graph of the many one function, because for these two inputs you are getting the same output, all right? So at least two inputs have same output, then that means it is a many one mapping, right? So this is a many one mapping. So if it is increasing, then decreasing, then increasing, decreasing, even once it decreases, increases, and then it start decreasing, then it is many one. So it should not repeat its values, not even a single point. Even if you draw this graph, it should not be continuous. You can take discontinuous function. Uh, Even you can take increasing like this, okay, and say this is the line, and decreasing like this. This graph is increasing and decreasing, but not continuous, right? Not continuous. And but it is 1 because anywhere if you plot a horizontal line, it will cut the graph only at 1 point. So you can't say that graph should always be increasing, okay? But if it is always increasing, if it is always increasing and continuous, always increasing for all x, then surely it will be 1 But if it is not always increasing, then you can't say it won't be 1 It can be 1 then also, all right? So that is the whole idea. I hope you have got it. So now what method do we use? Because I have told you that this is not the beginning or basics. Only those students can solve today's problems, those who have idea of calculus. So what I'm going to do, I'll check a given function whether it is increasing or decreasing or not. using the calculus. And what is that? Using differentiation. Okay, so if function is differentiable and its derivative is always positive, that means function is always increasing, then it will be 1 1. Let me give you one example. Say fx is equal to x plus sin x. Okay, I know this is continuous function, this is continuous function. Check 1 1 or many 1. Okay, so what am I going to do? I'll differentiate this. I'll differentiate this because it's a differentiable function, and I'll get 1 plus cos x. All right. Then I can see this is greater than or equal to 0. 1 plus cos x is always greater than or equal to 0 because cos x is always minimum value of cos x is minus 1. And equality will hold for discrete points. So graph of this will be like increasing, then slope 0, then increasing, then slope 0, then increasing, then slope 0. But it is always increasing. Okay. So if this equality does not hold for an interval, then it is called an increasing function. Okay. So it is increasing like this, which I got a plot. If you want me to draw the exact graph, then it is like this. Draw this line, y is equal to x line for support, and then plot this graph. X plus sin x. Sin x will be above this when sin x is positive, that means up to pi. And then sin x will be below this, x plus sin x, when sin x is negative. So basically it will be around this line. But it is always increasing. It is always increasing, all right? Always increasing. So that is the whole idea. That means it is always increasing. So f is always increasing for all x. So it is 1 1. Okay, 1 1 type of mapping. So I hope you have got it. If you give you another example, like y is equal to 1 upon x square plus 1. So no need to draw anything in this. You can see that plus x and minus x, right? It's an even function. Do you know even function? Even functions are always many one functions. So plus x and minus x. Minus x will give you, this is your input and this is your output. Same output. What will be the output? 1 upon x square plus 1. Like if you're putting plus 1 and minus 1, you'll get 1 upon 2. If you're putting 2 plus 2 and minus 2, you'll get 1 upon 5. Alright? Same output. So it's a many one function, clearly, right? Many one function. No doubt about that. So it's a many one function. So in this, you don't need to apply any differentiability funda or anything. Okay? You can directly use it and answer it. Let me write some random function, okay? And I'll tell you the logic to find it. But you'll have to use all the concepts, limits, and everything to crack this. Okay, this is a function, say. We need to check whether this function is many one or one one, okay? See how to do it. First of all, I'll see that this is a continuous, you're adding a lot of functions, okay? So no need to go to define derivatives and all. Don't try that because it will be linear then, okay? So that means you need to apply logic, nothing else. And what is the logic? Logic is this. You can see this is a continuous function. This is also a continuous function. This is also a continuous function. And this is also a continuous function, right? Continuous function for all x. If you check the limit x approaching to infinity, always do that. Always do that. Then this will be plus infinity. This will be minus 1 to 1, minus 1 to 1. This is pi by 2. So basically this will approach to infinity because this is the largest value, right? When x is approaching to minus infinity, fx will be what? Again, if you put minus infinity, this will give you plus infinity, and this will be somewhere between minus 1 and 1, minus 1 and 1, right? And this will be minus pi by 2. So again, it is going to be plus infinity. So you can see this graph of this function fx will come from plus infinity, it will go down, and then I don't know what will happen in between, okay? It might take some few turns, but ultimately it will go to plus infinity, right? It can't go to minus infinity, okay? It's a continuous left, it will have to take a turn and it will go up again. So you can see if it is coming from plus infinity and going to plus infinity, then definitely it is going to repeat its values. So certainly this function is many one function, okay? Many one. So I hope you have got this idea. So in this way you can solve some complicated expressions which are written just to confuse you, all right? So don't get confused. Just apply this logic into it, finish it. Okay, I hope it is clear. Now let's discuss onto and into also. So onto and onto into mappings. This is very simple. This is very simple. If range is equal to codomain, if range is equal to codomain, then function is called onto function, and its mapping is called onto mapping. All right. So range is equal to codomain means, let me explain it here only. That means here all the boxes must be filled now. Okay, I'll count it here. Now this is x1, x2, x3, and so on up to xn, and these are the outputs y1, y2, and so on up to ym. Now he's saying that range is equal to codomain. That means every element of set B should be mapped to some element of A, right? One or two. That is not a condition. It should be like x1 is mapped to this, x2 is mapped to this, x3 is also mapped to this. It might be many one. So we are not having any restriction on that. But all the elements of B should have a pre-image, one or two. Like y2, right? Y2 you can see have two pre-images, right? Y2 has two pre-images, and ym and y1 you can see they have only one pre-image. So every element of set B should have a pre-image. If that happens, then range is nothing but set B, codomain, okay? Which we have defined as codomain. So that means total number of mappings. How to find total number of mappings? Now these are your n elements. Put n elements into, these are again boxes. You can put more than two elements into same box, right? You can see this. So into m boxes, provided no box is empty. That will give you total number of onto mappings. So total number of functions were m raised to n. And when boxes are not empty, then this is the formula. I'm directly writing the formula MC1. Just remove one box and fill the remaining boxes m minus 1 raised to n. Okay, by doing that, two boxes are empty that you have removed two times. So you'll have to add that. So plus MC2 m minus 2 raised to m. This will count all those cases in which two boxes are empty. And apart from that, three boxes are empty case will also be included in this. Alternate, keep doing this. This is inclusion exclusion principle until this becomes one. All right. So this is the formula for onto function, and directly questions come from this formula. All right. And what is the formula for into mappings? A function is not onto, then it will be into. That means if all this range is not equal to codomain, if range is not equal to codomain, then it will be into mapping. All right. So that means at least one box is empty. So if at least one box is empty, then r raised to not r. Total functions were how many total functions were there? Total functions, total minus onto. Okay, this is the formula. So total was m raised to n and minus this thing, this. So yes, m raised to n will get cancelled, but you can write in this way: mc1 m minus 1 raised to n plus mc2 m minus 2 raised to n and so on, okay, until this becomes 1. So this is total number of into mappings. Now let's have an example, the same example which I took, function R to R. So codomain must be given to you. If it is not given, then you'll have to assume codomain as R, okay, all real numbers, and function is same as uh, f is equal to x plus sine x, okay. So you can see this was an increasing function. When x approaches to infinity, minus infinity, f approaches to minus infinity. When x approaches to plus infinity, f approaches to plus infinity, right? And f is continuous, right? So no matter it is increasing or decreasing, it is coming from minus infinity and going to plus infinity. That means its ranges are, right? Ranges are. So yes, this function is an onto function. So you need to find range while calculating the onto mapping. I hope it is clear. So now let's start discussion, solving problems. This is the first problem, odd, even. Okay, so let me quickly tell you odd, even also. If y is equal to fx satisfies f of minus x is equal to fx for all x, it is called an even function. Even function, and it will be symmetric. Symmetric about which line? Y is equal to x is equal to 0 line. Graph will be like this. This is an even function, okay? It is symmetric about y-axis. If I generalize this, if I write if f of a minus x is equal to f of a plus x, or you can write f of 2a minus x is equal to fx, then fx will be symmetric about x is equal to a line, all right? Now graph will be like this. So this is more generalized case than even function is a special case of this, all right? So graph will be like this. This is fx, this is x is equal to a. If you put a is equal to 0, this will become even function, f of minus x is equal to f of x, all right? You can see a plus x, the value you are getting at a plus x, this is a plus x, and the value you are getting at a minus x, all right? These two values are equal. That's what is given in this equation, right? So that is the case, that is the generalized equation. Using this, you can say function is symmetric about x is equal to a line, all right? Similarly, odd function, whenever you have odd function, I'll tell you what happens. If f of minus x is equal to minus of fx, this means f is an odd function. Odd function means, okay, so this is general equation like sin x is an example, sin x, x cube, x raised to 5, any odd power, okay. So f is an odd function, and graph of an odd function is symmetric about origin, 0, 0. It's like this. You can say value at a plus x is same as value of at a minus x, 0 minus x, 0 plus x, but they are of opposite signs, okay. Similarly, if you generalize it, if you write f of a minus x is equal to minus of a plus x, f of a plus x, that means f is symmetric about x is equal to symmetric about this point. This was 0, 0, now it will be shifted to a comma 0, all right? So yes, symmetry, the point of symmetry is on x-axis only. We can more further generalize it. We can take any point, okay? So I'll do that later through some questions. So this point is now a comma 0. So odd functions was in a special case of this, all right? I hope you understood the symmetry. Now let's begin the session. All right, so let me tell you, if you know the graph of sine inverse of sine, then graph of sine inverse of sine x is like this. This is the graph. Okay? This is pi, this is 2 pi, and so on. Okay. But if you plot the graph of sine inverse of y is equal to sine inverse of sine of mod of x, that means you are replacing x by mod of x. Then what happens? You just plot this part, which is right side of y-axis, okay, and take the image of this about y-axis. That happens when you replace by x by mod of x. All right. This is the graph of sine inverse of sine of mod of x. So using this, what is this value? By the way, this value is pi by 2, maximum value. When you put x is equal to pi by 2, you'll get pi by 2. When you put x is equal to minus pi by 2, you'll get minus pi by 2. So this lowest value is minus pi by 2. Okay. So graph is between minus pi by 2 to plus pi by 2. Now let's answer. F is an odd function? Certainly not. F of mod of x will always be an even function. Okay, remember that. Well, whether you put plus x or minus x in this, it will be an odd function. Sorry, even function. So A option is wrong. A option is wrong. And it's an onto function. So let's look at the codomain. Codomain is minus pi by 2 to pi by 2. And range, what is the range? Range is also minus pi by 2 to pi by 2. Clearly you can see this is the range. This is the range. So yes, range is equal to codomain. So it's an onto function. Perfect. It's 1 1. It's 1 1 function. No, not at all. It's not 1 1 function. It's increasing, decreasing, increasing, decreasing. So it's not 1 1. It's an even function. Yes, perfect. Even function. So it's a many one function. We have got the mapping of all types of mappings and even not. Okay, everything. So if you know the graph of this function, then you can do it easily. So that's why I told you that you need a lot of knowledge of calculus. I mean, not lot of knowledge, but for this practice session, you should have done graphs and limits, continuity, and monotonicity. So all these things we are going to use to answer these questions because we can better understand mappings of a function once we know all these things. Then mappings becomes an easier task, very easy task. And there was one question. So I'll give you one easy problem. Okay, so try this one. This is a very good problem. Alright, so let me do it. Now, if all the linear functions defined from -1 to 0 to 0, this is a very good question. So I hope you have tried it. See what to do in this. So this is -1 and this is +1, okay? And this function is onto function. So, and you need to draw a line inside this box. Why inside this box? Because range codomain is given 0 to 3, so you can't go outside this 0 to 3. I'll draw some lines and you need to tell me whether it is 1 1 and onto both. It should be 1 and 1 1 and onto. So to make it 1 1, it should be, a line is always 1 1 because it will be increasing, all right? So yes, this is 1 1. But what is the problem? Problem is this, that it is not covering the complete range, right? It is not covering the complete range. You can see this part, this is not included in the range. These points are not included in the range, all right? So range is from this point to this point, okay? That is the problem. So to cover this complete range, line should start from this corner to this corner, okay? Or from this corner to this corner. Only two possibilities. That means if you want to make this function onto, it will be 1 1. That is not a worry. By the way, we do not, he's not asking for 1 1 because it will be 1 1. So I hope you have got this point. So if you draw this line, this line, this is onto, because now it is covering the complete range. You can't draw like line like this. If you draw like this, then you are not covering the complete domain. See, there's no line in this portion. There's no line in this portion. So this is not a function at all. You need to draw a function between -1 and 1. Okay, so you can't draw like this also. Otherwise, it would have been 1 1 onto. Sorry, it will cover the complete codomain. Okay, so there's only one possibility like this, and the other possibility is like this. Okay, so these are the two possibilities, and these are basically diagonals of this rectangle, and you need to find the intersection point. So intersection point is the midpoint of 0 comma 3 and -1 comma 0, or the midpoint of these 2 points, this and this. So take the midpoint. So this point is P comma Q, and P comma Q is nothing but -1 by 2 comma 3 by 2. All right. So put P comma Q in this 2019 into P. P is what? -1 by 2 plus 2020 into Q. Q is what? 3 by 2. All right. So add them. It is coming out to be 3030. All right. It will come out to be 3030. Did we check the calculation? Oh, I'm sorry. P is going to be 0. I did one error. There's one correction. This point is basically 1 comma 3. So this is going to be, yeah. So answer is so this part will be 0 actually. This part will be 0 and answer is now 3030. So I knew the answer. All right, so this was the problem. Now let's do the another one, not this one, this one. Okay, so I'll try this. The similar problem was there in IIT-JEE 2020 advanced exam. So try this one. Alright, so let's do it then. I hope you have tried it. So fx is equal to, uh, if you take, because of this mod x, you'll have to separate this function into two intervals, x more than 0, x less than or equal to 0. So when x is more than or equal to 0, you can write x square by 2 plus cos x plus 1, and minus x square by 2 plus cos x plus 1. Okay, these two functions are differentiable and continuous. Yes, obviously these all three functions are continuous, so their sum will be continuous. So fx is a continuous function. Now let's see whether it's an increasing function or not. So if it is entirely increasing or entirely decreasing in all its domain, that means for all real numbers, then it will be 1 1, otherwise many 1. And onto we'll check later range. So first check f dash x. So it is going to be x plus minus sine x. All right, and this is minus x plus sine x, minus x minus sine x, I'm sorry. So when x is more than equal to 0, when x is less than equal to 0. You know, this is the graph of x, y is equal to x, and this is the graph of sine x. So you can see sine x is greater than x when x is positive. Oh, I'm sorry, when x, sin x is less than x when x is positive. That means x is greater. And sin x is greater than x when x is negative. Okay. So when x is negative, sin x is greater than x. Yeah. So uh, this quantity x minus sin x, this is certainly positive, right? This is positive. And what about this? Minus x will be a positive quantity, by the way. So minus x, if I show you minus x, then this is minus x. Okay, using graph we can, and minus sin x is basically like this. It will be reflection. Okay, so if you add minus x and minus sin x, it is going to be a positive quantity. Minus x minus sin x, because minus x is going to be, this is going to be a positive number, all right, and it will be greater than sin x for all x negative, for all negative values of x, all right. So this is again a positive quantity. Minus x minus sin x is a positive quantity for positive values of x, for positive values of x. Or you can do like this. If you take minus common, you can write x plus sin x, right? X plus sin x. So x plus sin x will be a negative quantity when x is negative. When x is negative, x plus sin x is going to be a negative quantity, all right? And minus of that will be a positive quantity. So you can say f dash x, f dash is positive for all values of x. And also, if you check x approaching to infinity, what is the value of f? So x approaching to infinity, this quantity will be, this is plus infinity, and these are some finite numbers. So f will approach to infinity, and when x is approaching to minus infinity, then x into mod of x, this will be minus infinity, right? So overall function will be at minus infinity. So graph is coming from minus infinity and going to plus infinity. So it will cover the complete range, right? Complete range. So what is this function then? This function is bijection. What is bijection? Bijection is which is 1, 1 and onto. So we have got 1, 1 and onto using differentiability, using derivative, and using the continuity and the limits at endpoints. We have got the range. So this function is bijection. 1, 1 and onto, bijective function. Now here is one very good question based on even and odd functions. So try this one. Alright, so let's begin the solution of this problem. So this function is, see, I'll tell you, um, this signum function is an odd function, this is an odd function, and this is also an odd function. So odd into odd is even. So overall this function is an even function. This is an odd function and this is an odd function, right? So you can see odd plus even is neither even nor odd. But if we're saying that this function is an even function, that means odd parts must be 0, because 0 is the only function which is even as well as odd, all right? So this odd part must be 0, so this part must be 0. Okay, so to make this part 0, how to make this identically 0? I mean always 0. Coefficients must be 0. If you want to say that ax cube plus bx is always 0, equal to 0 for all x, that means a is equal to 0 and b is equal to 0. So that is the condition. Okay, so I hope you got it. So they ask many such questions in which they add even as well odd function. Then they say that function is an odd function, so that means you have to make even part 0. And if they say this is an even function, then you'll have to make odd part 0. And how to make that odd part 0? By putting coefficient, which is a variable, is equal to 0. So in this you'll get two equations. So what is the coefficient of x cube? That is greatest integer of a square minus 5 times of greatest integer of a plus 4 is equal to 0. So it's a quadratic. You'll get greatest integer of a minus 4 into greatest integer of a minus 1 is equal to 0. So you get two values of greatest integer, 1 or 4. All right. Similarly, you get fractional part from the second equation. 6 times of fractional part of a, the whole square, minus 5 times of fractional part of a plus 1 is equal to 0. And if you simplify it, this is going to be 3 times of fractional part of a minus 1 after factorizing, and 2 times of fractional part of a minus 1. Let me check. Yes. So fractional part of a is coming out to be 1 by 2 or 1 by 3. Now what is your a? A is greatest integer of a plus fractional part of a. So you have two options for greatest integer and two options for fractional part. So let's write all combinations. 1 plus 1 by 2. Yeah. 1 plus 1 by 3. Or 4 plus 1 by 2. Or 4 plus 1 by 3. So these are the options. So if you add all these values, you'll get the, because you need sum of all possible values of a. So that is going to be 4 plus 4, 8, and plus 2, 10, plus 1 by 2 plus 1 by 2 is 1, plus 1 by 3 plus 1 by 3 is 2 by 3. This is the sum. So sum is going to be 11 into 3 is 33, 2 plus 35 by 3. So which option is correct? Fourth is the correct answer. Yeah. Fourth is the correct answer. All right, now let's solve again number of mappings. So this is based on the number of mappings. Let's finish it first. Try this one. See which option is correct. I will tell you in a minute. So number of functions from if f number of functions f from this interval to, okay, so we have 20 elements in A and 20 elements in B such that f of k is a multiple of 3. Okay, let me plot it first. I'll explain this. 1, 2, 3, 4. Whenever k is a multiple of 4. Okay, so let me write those numbers which are multiple of 4 in this set inputs. So he's saying whenever input is multiple of 4, output should be multiple of 3. So how many inputs you have which are multiple of 4? 4 itself, 8, 12, and then 16, and then 20, right? So these are the numbers which are multiple of 4, 5 numbers. So you have one condition that these elements must map to those elements of set B which are actually multiple of 3. So 3 and then 6, then 9, then 12, then 15, and then 18, and so on. All right. So these elements can map like these. You see, you have 20 persons, 20 chairs, right? So you need to map onto. So that means every person will pick one chair, right? So 20 factorial should be the answer. Whenever you have n persons, n seats, so n factorial is the answer, right? If every person will get a seat or every person to be seated. But in this case, condition is that these 5 persons will sit only on these 6 chairs. I mean 5 out of 6 chairs, right? So these six chairs can be used. I mean these 5 persons can use only these 6 chairs. That is the condition. So, but they need to use only 5 chairs. So for what would you do? You first would select 5 chairs for these 5 persons out of 6, and then these 5 persons can be arranged in 5 factorial ways. After that, 15 persons are remaining, so those 15 persons can be seated in remaining 15 seats by 15 factorial ways. So now there is 6 factorial upon 5 factorial, 1 factorial, 5 factorial into 15 factorial. Okay, this will get cancelled, and answer is 6 factorial into 15 factorial. So fourth option is the correct option. All right, now let's do one more problem, again based on permutation and combination. So try this one also, then we will discuss. Hmm. Okay, so let's do this also. You have x1, x2, x3, x4, x5, and x7. Seven elements in set A. And set B has only three elements, y1, y2, and y3. Now, what is the condition? We set containing 7 and 3 elements. The total number of functions have A to B that are onto. Okay, so you need to form onto functions. That means all three boxes. These are now boxes. Okay, so you need to map all 7 elements to these three, y1, y2, and y3, and no box should remain empty. But further, he has imposed one more condition. What is that condition? Now, if there exist three elements x in set A, that means three elements of set A, such that f of x is equal to y2. Okay, that means he's saying that three elements will go to box number 2. So which three? Any three, like this, or this, all right? So these three will go to y2. So first of all, which three? So 7C3, just pick three elements of set A and put these three elements in set in this box y2, all right? So you can put that in one way only, right? You don't need to arrange them inside the box. You're just putting it. So you have selected three elements, you have put these elements in y2. Now how many elements are remaining? Four elements are remaining, right? Four elements. Let me mark these. One, two, I missed x1, x2, x3, x4, x5, x6 is missing. X6 and x7. All right. So now you need to put these four, which I have circled, in y1 and y2, but no should be empty. So total number of ways to do so is 2 raised to 4. First element 2 options, second element 2 options, third element 2 options, fourth element 2 options. So 2 into 2 into 2 into 2. So 2 raised to 4. But there might be two ways in which exactly one box is empty and all the elements are gone to one box. So all elements are gone to y1, then y3 will be empty, and all elements are gone to y3, then y1 will be empty. So we need to remove these two cases. All you can apply that formula, r raised to n minus rc1, r minus 1 raised to n plus, and so on. So in this 2 raised to 4 minus 2c1, and this is 1 raised to n. That's it, finished. So that is same as 2 raised to 4 minus 2. So this is 7c3, let's write like this, and this is what? This is 14. So 14 into 7c3 is your answer. So which option is correct? Option A is the correct option. All right. Okay, now let's do this one also. All right, so you try this sum. We'll continue from here. Let's take a break and then we'll start from this question. So I'll discuss this question after that. Okay. All right.